This is the second revision of my AI-powered solar weeder. It drives around and uses image classification to look for weeds. When it finds one, it focuses this large Fresnel lens over the weed, lifts the lid, and uses the focus power of the sun to burn the weed where it stands. Now, it hosts its own Wi-Fi hotspot, so to control it, we just connect to the weeder Wi-Fi, navigate to its webpage, and tell it what to do from that webpage.
In this section, we will cover the slicing, printing, and assembly of all the parts for the weeder. If you're familiar with 3D printing, go ahead and jump about 4 minutes ahead. You can print all the STL files at the bottom, and in about 4 minutes we'll start the assembly process. If you're totally new to 3D printing, as I was when I got started here, let me explain just a little bit how this works. So what you see in front of you here is a sliced 3D model. The files that are attached are STL files, which are just basic 3D models. You've got to then take those and translate them to whatever your 3D printer is so that it knows how to actually print it. And what I mean by that is if I zoom in here, you see there's multicolored lines. Those are actually the filaments that the 3D printer will lay down. Each of them represents a different thing. So a slicer takes the 3D model and turns it into this that your 3D printer can actually use. Now, I used a really big 3D printer for this stuff because the lens, the Fresnel lens, is large. It's 12 inches around. This is like 350 mils from the top to the bottom, so you've got to have a huge 3D printer to make it work. I chose the Anycubic Cobra 2 Max, so I'm going to show you how that works here. You can choose any big printer. You can go to your local Fab Lab or probably rent time on a printer somewhere in your area where you can have a big printer to print these things out on. And they take a long time, many days to print all this stuff. So what I did is I grabbed I went to the Anycubic firmware and software page. I grabbed the Prusa Slicer filaments profiles, and then I came over here to Prusa Slicer. This is an open source slicing program, and I just said open a new project. The first thing I did was I imported that config that I just downloaded from the Anycubic website. So this one right here is like a generic, and then I made a few special settings here. I'm going to suggest that you print all of this in PETG, and that's because it'll last a lot longer outdoors. PLA is more common, but it'll break down in the sun over time. So what does that mean? I went to these two tabs right here and made some edits from the generic version. Specifically under speed, I changed the speed of all of this to 30 and the speed of the first layer to 10. That is dreadfully slow. That's why this takes so long. But PETG on this printer just goes slow. PLA is a lot faster. And then second, under the filament settings here, under advanced, I set it to PETG. The filament up here, I set the nozzle to 230, the bed to 80, the other layers to 230. That's how hot the print head is. And then the bed is 80 degrees Celsius. So these are the settings that you need to set up. And then you can experiment with these others. I chose an infill of 50% and a no brim. So next step is you go over to import one of these STL files. That's what's actually down at the bottom of the page here that you can link to. We're going to choose the lens holder here. This is the 3D model. It doesn't have any of those little lines on it. If you zoom in, it's just a solid green thing. Now that we've got our print settings set up, our filament settings set up, and then our infill and no brim, we can go down here and click slice. And it'll take that 3D model, and for all of that setup that we have, whatever printer type you have and whatever you choose for your filament and print settings, it'll slice it. And you see we get a very similar looking set of little lines here. And then all we have to do is export that G-code, and we get a file here, save it wherever you want, and that's what you're actually going to put on a USB stick. Plug that USB stick into your 3D printer and hit print. And as long as you've got your PETG filament set in there, it's going to take probably hours to days to print that off for you. Now you want to repeat that process, so we'll go over here to New Project, Import a new STL file this time. So let's choose the lens arms right here. So now we've got all of these lens arms and the little holders for the servo motors. We'll click the same slice now, and it'll take its time slicing, slicing, slicing. This is another place where infill, having it higher, gets these. Infill basically means each of these arms is going to be hollow in the middle, and it'll have like a honeycomb pattern. And if you choose a higher infill percentage, rather than 10% full inside these hollows, it'll be 50% full. And it's going to be a lot stronger the higher infill you choose. So 50% is a fairly good number. You want strong arms. These things will bend or deform if you don't have enough infill. So now we've got this again, we can export our G-code, and you're going to do the same thing for all 4 files, get all 4 of them for your 3D printer, hit print, wait a couple days, and when you're all done, you'll end up with all of these 3D printed parts, and you're ready to assemble them. Let's go there now. Hey, there's 2 other files that need to be printed. I realized after I filmed it that I didn't put them in there. There's the body and then the cover. And these are fairly large prints and will take quite a while, especially the body. It's really tall.
Okay, you've got things printed. The holder, the cover, all of the arm assemblies that will go on top, and then in another big print, the body, wheels, screws, etc. It's time to put all this together, and we're going to start here with the holder. So the lens should fit in here pretty easily, and you can actually take just a bit of super glue and daub here, 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 and then I actually accidentally broke this, but daub a little bit here and a little bit here. You're going to put a strip of Velcro on the underside of this thing for the camera to sit, and so that just keeps this whole assembly here together. The next thing you're going to work on is these photoresistors right here. These photoresistors fit nicely into your pinholes right over here, and this forms the sun tracker. So you're going to need to get 4 of these. Next up comes the pinout on here. This on this side here is your power, middle is ground, and the left side is your signal coming out. Now what you're going to need to do here is tie together all of the powers, all of the grounds, and all of the, the signals will come out separately. So you're actually going to take every one of these power pins here, 1, 2, 3, 4, just run a wire around. What I used is this stuff here. It's 18 gauge wire. This is actually doorbell wire. And I just bent it into shape with the red bend here so that it touched every one of those 4, and I soldered it into place with my little soldering iron. Do the same thing with ground, and then run your 4 signal wires out. Now I chose to use something like this here. You grab 5 of these right here, you've got your power, ground, and then 4 signal wires coming off of there. So rather than making you sit through me solder all that, here is a final result here. So you've got a ground wire, this white one here. It's connecting the middle pin here, and there's a wire coming through here to the middle pin over here. And this white wire runs all the way around over to here, where it also connects to this external wire here. Here's the middle pin and the middle pin. And then you've got a cross going through here that's connecting all of the power pins. And then in here, this black wire connects to the center of that cross through there. And then all of the signal pins are just soldered directly on. I cut the ends of these off. And over here you can see you've got 5 wires coming out, a power and a ground to the black and white, and then 4 signal wires. Now this stuff right here is an electrical insulator goop that acts as a glue. So after I had checked these connections were made with my multimeter, I just set the ohm meter and connected to pins on this side and then pins on this side to make sure everything was electrically connected. Then I grabbed some of this goop and I covered the whole thing with that. And here's that goop. It's something I just got from the local hardware store. I think it's actually typically used on electrical wires in your walls, but it works perfectly well here. So that's what it looks like on the underside, where you have these 4 photoresistors sitting on the top, separated into quadrants, and then electrically connected on the bottom here. And then this whole lens has been super glued just at 4 little dots with a little bit of Velcro, as I mentioned, right here to hold this together. And then a Velcro right here, sticky Velcro that will hold our camera in place just a little bit later. So let's take this whole thing. We also have, of course, our cover here. we're going to take this whole assembly and set it aside for a moment while we work on all of the arms. Okay, here's our arms that have been printed. This is the first one. This one will fit right here. The third one will go here. This one here controls the left and right tilt. We call it a roll. This controls the tilt, so as it moves forward and back, it tilts that lens assembly right here, forward and back. And then this one here, as well as this other little guy, will control the lid. So when the lid needs to open, this will do the lid opening right here. So let's start with our base here. This right here, this point right here on the underside, is going to be the connection to our actual body of the weeder. Okay, we're going to open up our servos. Grab the first servo out. These fit pretty snugly in here, like so. And these are 1/2-inch wood screws. I think they're number 4s. Honestly, you can use any short screw that you have. These aren't under a ton of tension. So just drop it right in here. And you've already got the holes pre-drilled as part of the manufacturing process. So you just have to screw this all the way in. For this connection, you're going to use this cross piece here. And when you put it on, you're actually going to take one of these sides off completely. You can use any clippers that you've got. So we're going to take one of these sides off, like so. I'm going to do the same thing with this one. It's just a straight piece. I'm going to take one of the sides off. And I'm going to use this to check the range of motion on this thing. So if we back drive it all the way to the, that's clockwise, now we're going to go anti-clockwise, come all the way back to here. We can see that, say right there is, it'll be equal on both sides. This has got only 180 degrees of motion, and we want to set this right at the 90 degree. So what I've done here is I've sort of checked it can drive to here, and then over to here. And so this right here is the midway point. So now we know that our motor is set to the midway point. We're going to take this piece here, we're going to set it in like so, and screw it in. So there it's set. Now we're going to take this piece right here. You can see it's already got holes pre-drilled, 2 of them, 1, 2, and they should match up with what we just put in here. So now we line those up like so, and we can sink screws in here and here to make this connection. Now I'm going to use the screws that came with the servo here. These are just little guys, but I am going to clip them off so that they're not quite so long. Okay, we have our second servo motor here. We're going to screw it in. And we need to do the same thing here where we find the range of motion on this. So we're going to attach the same single piece that we had before. We're going to run it around. Okay, there's the extremity of its motion right there. We can set it like so. And we just want to check that it drives to somewhere over here. So we'll call that there. Right there. Now that means that right here is somewhere in the middle, somewhere close to the middle. This thing is going to need to be able to move between here and here. So the 180 degrees is an arc across the top, and that's really what we need to make sure of. So that when we attach our piece here, that's what we're going to be getting. I'm going to go ahead and drive this screw in now. Okay, our next piece is here, and this little hole right here is how it's going to be connected onto the arm that we have sitting right here. This is actually a little bolt and nut that I picked up from the local hardware store. It's a number 1. I think it's a 5/16 long or maybe 3/4 long. The reason I'm being careful is
This connection right here is going to move back and forth, and if we were to just screw that in place, it would be it'd eventually come out. So we're going to bolt it in place. So I used a drill to make that just a little bit larger of a hole before I put the bolt in. It wasn't fitting otherwise. Okay, now we've got a connection that's solid, but won't come undone as this thing goes back and forth. Okay, we're going to pull the same trick here. Clip off one side and check to make sure that you can travel from this position here to this position here. So what we're going to do is we're going to attach this guy right here. We're going to find the limit in this direction. It's right there. So let's set it like so. There's our limit in the anti-clockwise direction. And it's going to come all the way back around to here. This is our lid. It's going to open and shut. Now its actual travel is going to be 180 degrees from here to here. So like so is what it's actually going to travel. Now we want to screw it in place since we know that this right here is the halfway point. Now you need to use that same piece, the short piece right here. This has two little holes. Those are going to match up right here. And this will all travel as one arm together. You will eventually trap this in here like so. And that will be what actually controls opening and closing the lid. So for now, just set this right on here and screw it in place. Before we connect all of this to our lid assembly, we want to put this piece on to the bottom right here. That's actually going to connect onto the body. So there will be one more servo motor that'll actually be the connection point here. So let's go ahead and screw this one in place. Again, these are just the screws that came with the servo motors. So there you have it. The arm assembly is complete. You can always take this piece of the arm assembly out when you need to drop a screw in there and actually make the connection to the body. We'll wait on that though. Okay, now it's time to make the connection to our lens assembly. So we've got all these pieces out here. We can first fiddle this in right here. You can move this up just a little bit out of the way. And this is a fairly simple connection. Make sure that you do this connection right here to the bottom first. That'll get your lens assembly in line. All right, we have 1, 2, 3 connections to the lens assembly here. And we're gonna go ahead and just use these same screws that we have left over from the servos. You could just as easily put a little loop of 18 gauge wire through these holes. You just need something that's gonna keep these from taking off when it's in operation. Okay, your lens assembly is completed, and now it's time to work on the body. Okay, quick overview of the layout before we get into the details here. Raspberry Pi sits here. DC buck converters sit here, 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 so 6 total. This motor here and over here is going to control the wheels. This little printed part here has a D axle that fits just over that, and then it turns the inside wheel right here. This axle will fit into this little axle holder here. There are ball bearings that fit right inside there. And then, of course, you'll have wheels here, 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 here. This is going to power the wheels, as well as these worm drive gears here. So these are actually what control your Z axis. You've printed some screws like this. They have a D shaft on them also. So that's going to fit right over these worm gears here. And then this piece here fits right in here and goes up and down. So this is essentially what allows you to focus your the lens by going up and down, and it will be controlled with these things right here. The last servo motor that we haven't yet put together will sit in this box right here, and that will allow the whole thing to swivel left and right. So our lens assembly will sit on top of this servo motor here. Let's start a bit more simply though. All we're going to do initially is get our batteries in here and get the batteries wired up so that this power distribution, this is going to be our negative terminal down here, sorry, positive terminal down here and negative terminal here, are wired up. We're also going to put some just wire nuts on there so that we can disconnect those easily and then reconnect them for charging so that we can connect it up to a LiPo charger. So these are the battery cells that we're going to use, and they are a tight fit in here. You're actually going to put the button side in first and then push it down in there, and that'll be tightly fit, connecting to the top and bottom. So the first thing we're going to use is this stuff, sticky copper tape. So we're going to cut a few pieces and add it in here so that we can get access to all of these terminals. Okay, now we have a negative terminal over here, and it's overlapping right here. This piece here connects the top of that battery, the positive to the negative of the next battery. Now the positive connects to the negative of the next battery. And finally the positive terminal here comes around this corner using some copper tape, and we have a little solder joint right there. So let's install some batteries and see if we have connectivity. Okay, we pull out our multimeter and we're going to check here at 11, 12 volts. So this is all connected, looks good. All right, the next step is we're going to make this our negative terminal and this our positive terminal. And you can see there's little screw holes all the way along here so that we can screw in a bunch of things to get the electrical connections. So we're first going to take copper tape with a little bit of solder joint here and make the connections to these two stubs that we have. Okay, now we've got copper tape all the way across the top and bottom here, and I poked little holes just so I would know where my screw holes are in this side. We're going to check and make sure we have electrical connectivity. Sure enough, 12 volts shows over here on the multimeter. We can proceed. Next up, we're going to insert these Cytron motor controllers and these little buck converters. Now these five, 1, 2, 3, 4, 5 will all have to be set to 5 volts, and we'll be turning this little potentiometer screw here to get them to 5 volts. This one over here needs to be 3.3 volts. It actually powers the sun tracker array, which runs off of 3.3 volts. I tried not having so many of these, and the servos took enough power that I couldn't, most of these buck converters only supply like 1 or 2 amps. And if you loaded it up with a bunch of servos, it was just too much for it to handle. So I went ahead and separated it out, and I separated out the power supply for the Raspberry Pi as well. So what we're going to do is we're going to wire our in plus and in minus. That's the 12 volt positive rail here and the 12 volt negative rail right here. We're going to solder some wires in those, and then we're going to solder the outputs over here, and we are going to twist this little potentiometer until we get to 5 volts. All right, so now we've got some sheet metal screws here. These are number 6 by 1/2 inch. And we are going to try to use them to connect this guy up. You see I've put little loops at the end of each of these, and that will wrap around the screw like so. And then I'll just screw the screw right in. Okay, so bad design choice on my part. It's hard to get this screw turned in. I ended up having to use a needle nose pliers to get in there and turn it.
But now you can see we've got this buck converter in place. It's connected to the positive and the negative terminals. And we're going to twist this output right here until our multimeter shows 5 volts. There we go, that's 5.045. So now I'm actually going to disconnect this thing. So this is why I put these in. These loose ends out here, until they're plugged into a servo, they're kind of a hazard. So we're going to go ahead and completely disconnect this negative terminal here. And now we'll do the same on the positive, actually, just to be safe. So now we've completely disabled this buck converter over here. And even if these two ends touch, it doesn't make any difference. So let's go ahead and do that 4 more times on 5 volts, and then 1 time on 3 volts. Okay, we've got these power supplies in. You can see we've got little buck converters here, here, all through here, and then we've also connected these up. The power comes in to these bars over here, and I've routed it around behind. I ended up having to put screws in both directions so that I could connect my terminals here. So let's go ahead and wire this up, do a little smoke test, and then check voltages. First we connect the negative, and then, yep, I see lights coming on. No smoke, hooray. Alright, so let's do some power checks here. I adjusted a few of these already. So we've got, let's see, 5.05 there. 5.04 there. This one, I believe, has not been adjusted at all. Yeah, so we got the full 11 volts coming through there. Okay, so there's our 11 volts on the voltmeter. And we're going to have to turn, I believe it's counterclockwise. And you have to turn quite a ways before it even starts registering. Oh, a little too far, 4.8 volts. Bring that back up to 5.03. Perfect. 3.34, there we go. 5.1, that'll work fine. All right, let's disconnect these again, so we don't have any accidental smoke. So there you have it. Our power system is put together, and we're gonna go ahead and put the rest of these motors in next.
Public service announcement before we go on. These batteries that I chose were advertised as almost 10 amp hours. They're actually less than 1 amp hour. So you got 3 choices. I'm not happy with those batteries, basically. You got 3 choices. 1, you can charge like every 45 minutes of operation. Otherwise, one of the batteries will fail and you'll have to replace the whole thing. 2, you could just get a better brand off of Amazon or whatever. Just make sure it's the same size, and they have a little button on the end. They're standard 81650 size. Or 3, you can do what I did, just grab a lithium polymer battery that's a 3S and use that instead. You can just wire it straight into those 2 that you have there. The 2 terminals, that would have been on the battery case. I wasn't happy with them, and I didn't have any other lithium ion 18650s around, so I just used a lithium polymer battery instead.
So these motors are 50 RPM with a little 6mm D drive. E-axle. I believe these are number 6 machine screws, and this is an 8mm D shaft. All right, after a bit of work, we've got these 2 installed. Now we need to put these on. These are D drive, and they may need to be cleaned out just a little bit with a drill. This is a tight fit, so sometimes I take a tiny drill bit and just clean out the opening. Once you get it started, it'll go on pretty well. Now we're going to take that same drill bit and we're going to just clean out these screw holes so that we can put our final final motor in. Same trick as before. We want to make sure that we're the 50% line We want to make sure that the 50% line is pointing that direction, so the same direction as the wire is coming out. So we give it a twist this way. Now we note where that is. Twist. And right there is where it comes around, so right there is the 50% point. And we'll go ahead, feed this in. Okay, there we've got it in. Wire's coming out this way. We actually have to clip off the front nub of this to right about there. There we go, just like that. Now it's connected, and we can set that right in. Now it's time to put on our center drives. They're gonna slip right over here, and we need to make sure that we line up the D drive, and if we need to, clean out a little bit of that. You also wanna make sure that the face that was touching your build plate is towards the inside, like this, or flipping it over like this. This is the side here that was on the build plate, because that's how the wheels will mesh up with it. Now that we got these in, we can go ahead and connect them up. The worm gear and the motor on this side will connect to this Citron. Don't worry too much about the order here. You can switch it out after you've done just a little bit of testing to make sure that things are turning in the right direction. In other words, if it's supposed to be going down and it goes up, or vice versa, then you can just switch the motors here, switch these two cables, and you'll get the other direction. You also don't really have to worry about side A versus side B, because as long as you get the correct pins on the Pi connected up to side A or side B here, you'll be controlling the correct thing. Again, that's something that we'll test out here in just a bit. All right, all the motors are hooked up again, so we're going to go ahead and reconnect the power and do a quick motor test. All right, now these Citrons have little buttons on them right here. You can actually control, you can hear it there, see it running here. You can control your motors directly from there. Same thing down here and over here. We can actually run this down just a bit so that it's actually sitting where it's supposed to. One thing before we stick this in here, you may want to take some sandpaper and sand it off. I just gave it a try and it was just a bit too tight of a fit. So you can see this side's going down over here. Now we're going to do the same thing over here. Now we can actually kind of run both sides down. There we go. That's a good run down. We're going to bring it back up now. That seems pretty solid. Onto the wheels. You got to have your metal axle rods already cut. You're going to shove this in here. This is a real tight fit here. So give it just a little tap to get that in. And then I pre-drilled a pinhole right there so that once I get this put in place, I can actually run a little linch pin right there, and that'll keep this from sliding out. Now, you're going to have to insert these ball bearings on both sides of each of these before you put your axle through. We're ready to insert this, but what you're going to notice is you can't just push it straight in, because the teeth here don't want to mesh up with the teeth right here. They actually have to all be pushed in at the same time for that to work. So we first have to remove the center gear. Now get it to mesh up with these other two. I like to put it nice and high to start like this, and then I slowly let it work its way down like so that it's in the middle of those. Sorry, set it up like this, and then slowly let it work its way down so that it's in the middle of those two. So you're actually going to have to put all three of these on at the same time. So I put this in on the top here, let it mesh in with the gears, make sure that it's in the right direction, same as the axle that it's trying to connect to, and then give everything a nice push, And make sure you're... Now, if you want to give this a test, you can reconnect your power again and come over here to the... Let's lift that up. So right there you can see those wheels are turning, and you can test them with your little Citron driver over here. Good enough. Disconnect your power and repeat on the other side. Okay, the last thing to assemble is the lens assembly. You've got to get this set just right so that it's on top of the servo motor here. Like so. Give it a little wiggle. And now you actually do want to put that last screw in. You can lift this up out of the way without breaking anything, and now you have access to that last screw right there. All right, that's now screwed in, and we have a fully assembled weeder. Next thing we want to do is get our Raspberry Pi prepared and then wire it up.